Just a few words for those of you that this is your first LJC event, or joining us from around the world, or tuning in afterwards. A bit of background and a bit of a call to action here. Yeah, for those of you that don't know the LJC, it is the London Java community, or the London Java user group. So we're a very well established and highly active group. We've been going for over 13 years now, and we've got 7,500 members, and we've run over 600 events within the LJC. But what sets us apart, what we're really about, is sort of beyond those numbers, the fact that we really believe in the power of community, and that as a community, we can do much more than us as individuals. And this hits all over the place with what we've done. So firstly, the learning and development side, obviously things like today, like bringing everyone together to learn. It's obviously complete for free of charge. Thank you, Ricardo, for giving up your time there. Also on the tech side as well, initiatives like Adopt OpenJDK, Adopt to JSR, they came out of everyone in the LJC getting together and creating things there. And more recently, the diversity and inclusion efforts that we've got going on. We've got a lot of stuff happening that we're now able to do as a community, much more than individually. So if anybody's interested in getting involved in anything there, giving talks, the diversity and inclusion stuff, getting more involved in the tech side, talk to me afterwards, see me on LinkedIn, Twitter, or anywhere. So as for who I am, my name is Barry Cranford. I'm the founder of the LJC. I'm not a developer myself. I'm actually a recruiter. I run a company called RecWorks. So at RecWorks, whilst we are a recruitment company, we believe that recruitment can be a force for good beyond just getting people jobs. And again, that covers a bunch of different areas. So some tangible examples of what we've done include the events. So we've organized the 600 events. We do this around various other communities as well, the LJC, the London CTOs. We've got a mentor introduction community, a bunch of different things. And we also see our role as constantly bringing new, fresh ideas and initiatives into what we do. So a few different things we've got that we've just recently started, the Aspiring Speakers Group. So if you're looking to get started on conference speaking, we can help there. And the Aspiring CTOs as well. So if you're interested in stepping into a CTO role at some point in your future, then give us a shout. Everything we do though is powered by recruitment. So we literally don't make any money from any of the community efforts that we do. So if anybody is interested in looking for a new job or hiring developers, then again, come and talk to me. Anyway, I'll get out of your way for this evening then and hand over to Ricardo. So just a few words about Ricardo. If you don't know him, he is a developer advocate at Confluent, which is the company founded by the original co-creators of Apache Kafka. He's got over 20 years of experience working with software engineering and specializes in service-oriented architecture, big data, cloud, and serverless architecture, and has previously worked for other vendors such as Oracle, Red Hat, and IONA Technologies. And lives out in North Carolina. So Ricardo, I'll hand over to you then.
All right, thank you, Barry. So I want to share my screen here and we can kick things off. All right, hopefully you can see my screen.
Yeah.
Yep, all right, cool. So also hopefully you can see my first and probably the only slide that you're gonna see in this presentation. So thank you, Barry, for the introduction, because I actually brought this presentation here that literally has only 2 slides. That's it. I mean, I only brought it for introducing myself and talk a little bit about my background, but you already done this. So we can skip straight to the actual content that I would like to show, which is the GitHub repository. So the TLDR about this presentation is that it's gonna be 100% practical. Of course, I'm gonna do it, you're gonna watch it, but I'm not going to spend too much time like speaking about concept and fundamentals. This is going to be, the intention of this presentation is going to be a little bit different. The intention is for me to give you the tools, the right tools for building your first connector with Kafka Connect, right? And the reason for this presentation came from the experience that I've had myself, and probably I would say that 99% of the people here also face the same issue, which is, all right, I have a job to do, and this job involves kind of learning and being good a little bit of this specific set of technologies. But ultimately, what I need to do is to deliver this by the end of the week, such as, for example, creating your own connector, right? So I think the point here is that you're going to have the tools that you need to build your own connector, but not necessarily have to be really good at Kafka Connect, right? This is not the same to say that you should not understand Kafka Connect in details. For those of you that know Robin, for example, that also works as a developer advocate for Confluent, he delivers probably the best talks about Kafka Connect, right? And I highly encourage you to watch the talks that he has made available through the internet. But what I'm trying to say here is that for some activities, such as creating connectors, you don't necessarily have to be that good in Kafka Connect. So the whole purpose of this talk is to give you those tools, all right? But of course, if you're new to Kafka, and if you're, more importantly, you're new to Kafka Connect, feel free to ask questions. I'm here to help, right? If I don't know these questions, I probably can follow up later. Maybe I can bring Robin, which is the actual expert in Kafka Connect from the team later on. But I think you have the ability to ask questions at any time, right? We probably don't have a Q&A session in the end, right? I would rather bring those questions throughout the presentation, and I will give you some specific pauses during the presentation for bringing those questions, all right? So I'm gonna skip this because Barry already introduced me, so let's go straight to the point, which is, as I told you, giving you the tools for writing your own connector, right? So I think this presentation is going to be extra useful for you and for me specifically, because I've delivered this presentation before for other groups, such as data engineering groups, big data groups, also Kafka, of course, Kafka groups that are not necessarily full of Java developers, right? There's a bunch of other type of developers, so from other programming language or technologies. So I would guess this, for you, this is going to be extra fun because it's all about Java. So I think it's gonna make my life a little easier, especially during making examples. Like there was the situation where I was in a big data group, and then I make the analogy for the JCA framework, the Java Connector architecture. And everybody was like, all right, what is JCA? So what are you talking about? So I think my analogies are going to land more freely here with you than with other groups, right? So the first thing I would like to share with you, and this is going to be a link for this GitHub repo here, to which I'm going to pass on the chat window. If I find the chat window, here is the chat. All right. So yeah, I'm going to pass here. Robin already made a comment. Yep, thank you, Robin. Here's the link for Robin's presentation. Like I said, Robin is probably the best person to talk about Kafka Connect. Right? I've learned everything I know literally from him. So you're in good hands watching his presentation, right? So I just share here the link for this GitHub repo. And the first thing I'm going to do, we're going to break down this presentation in 3 parts, right? The first thing I'm going to do is a quick demo. So I'm going to clone this repo, just to show you that you can literally rely on the code that has been written there, right? I'm gonna spin up some Docker containers that are gonna leverage the connector that has been built with this code, and we're gonna do this demo and walk you through a little bit of the concepts, right? Later on, I'm gonna walk you through in the code itself, so you can have a little bit of understanding about, all right, I am a Java developer, I know how to write Java code, but what are actually the Java classes that I need to write, and what is the relationship between them, right? So I'm going to explain all of this to you. And lastly, I'm going to discuss a little bit about what are the common pitfalls, even for experienced Java developers, that you should avoid in the code, all right? So let's break down in these 3 parts, all right? So let's start with the easiest one, which is clone the REPL, right? So I'm going to, everybody is listen to me, right?
Yeah.
Yes. Okay, good.
Yep.
Because I just wonder, are they listening to me? So maybe I'm mute. I don't know. Okay, so let me grab the URL for the from this GitHub REPL. So what I'm gonna do here is to go to my temporary folder. I'm gonna make a folder here called London, right? I'm gonna enter this folder here. So everything is going to be stored on this London folder. And then I'm going to clone this REPL here so we can start with a fresh version of this code, right? And then I'm going to start, what is the name of the project? It should be Kafka, yeah. So I'm going to start my code, passing this folder as parameter, so we can inspect this code using code, which is a little bit redundant, I know, but you got the idea, all right? So, like I said, the second part is going to be all about walking through the code, so I'm not going to bother on this right now. Just let's do a quick demo, which is, I am going, this code is all about Maven, all right? So you need to have Maven as well as a Java installed on your computer to work with this. So the first thing you want to do is to package this project. There's some minimal tests, unit tests that I've put it here, but they were more like to emphasize what type of unit tests you should write. But I would highly encourage you to write your own tests here, right? So that said, there's a comment here that I'm going to make later about the deployment archive that is being generated here, but let's keep this for later. Like I said, the deployment archive has been generated right here in this folder. This is a zip file. So what I'm going to do now is this code, I can close this. This code includes a Docker Compose file. Because I've thought, all right, one of the struggles for Java developers entering in this Kafka world is they spend a lot of time kind of like do the plumbing of connecting the runtimes in order to effectively start working with the technology. So I've give you this Docker Compose so we can spin up rapidly all the services that are needed, like Zookeeper, the broker, and the Kafka Connect instance. So you can start jumping straight to the code part, right? So all you have to do is start up your Docker Compose, right? You need to have Docker Compose, install it in your machine, right? And the service that you are going to be particularly interested to is this Connect container here that, as the name implies, manages the Kafka Connect runtime where connectors are deployed. So just a parenthesis for those of you that are not familiar with Kafka Connect works, Kafka Connect is a runtime framework for connectors, right? Is like the concept of JCA, Java Connector Architecture, for in the context of application servers. So the application server are going to be this little JVMs that you can like scale out and form your own cluster. And this is the runtime part, right? And the JCA is the specification that you're going to follow to write your own connector. So this is what we're going to do here, right? So the Kafka Connect instance is up, right? Let me do this for a second. Let me minimize those windows over here because they are annoying when you are presenting. And the Kafka Connect instance is up. And if you strictly follow the instructions here from the GitHub README, you're going to see that first step is to clean package, right? And then you're going to Docker Compose up, which we've done already. All right. And thirdly, you are going to deploy the connector. So what you have here is a Connect instance running with no connector deployed, right? So how you deploy a connector in Kafka Connect is literally a REST API call. So yeah, I'm going to simply copy here, paste it here. And as you can see here, the runtime already detected that a package has been requested for deployment, right? And it has been deployed already, right? So I'm going to explain the code later, but what this code does is to periodically try to generate from, I think is every 5 seconds, it generates a sample data, right? And this data is sent to a Kafka topic, right? So since the data has been sent, it's being sent to a Kafka topic, we can monitor that by spinning up a consumer for that Kafka topic. So you're going to see that there's an instruction here that you can use a Kafka console consumer to inspect a topic called source one, which I'm going to do it here, right? And yes, it's working. So as you can see here, I think it's every 5 seconds. Yeah, every 5 seconds-ish. A record is sent to a topic. Actually, a record is generated. The connector writes these records into the Kafka topic, and then we are able to follow up here. So as you can see here, it's working. And this is the proof that you can like literally use this code to build yours, right? So the strategy here would be, all right, you're not going to leverage the simple code that I've provided, but if you once you've learned which class and method and callbacks does, you can simply replace with your own logic, and there you have it. You have your own fully connector up and running. So like I said, I would like to provide you these tools so you can jump straight to the delivery part, and then like in parallel to all of that, you can sit down, take some time, learn Kafka Connect, and learn how the framework works, right? So I think that speed up a little things for you. I'm going to stop this consumer over here, right, for a second. I'm going to actually close this console tab over here. And remember when I told you that the first thing you need to do after you have Kafka Connect running is deploying the connector, right, which is this REST API call over here. So as you can see here, this REST API references a basic example.json file, right? I'm going to show you right here. So you can see what this file does. Examples, base example.json. So here's the part where it's so good to talk with Java developers. Analogies become so easy, right? So remember the old days when we have Java E or J2EE for the older ones, where you would deploy a JB or a servlet, you would pack them up in a jar file or a web or a WAR file, and within this WAR file or jar file, you would include something called a deployment descriptor, right? Remember that? So cool. So this is what will be the equivalent for a deployment descriptor in the Kafka Connect world, right? Technically speaking, this is where users, not developers, the users are going to specify the configuration that are needed for the connector, or technically speaking, is where you as a developer are going to externalize all the properties that is going to be filled by users or operators, right? It's that simple, right? So this is the configuration file or deployment descriptor for to remember the old days. So this is where I've told you that when you provide the REST API call, which is a post, right? You specify that the payload, the content type is application JSON, you provide this JSON payload, and then you're going to reference the endpoint of your Kafka Connect cluster, right? /connectors. That's how you deploy a connector, right? Using the same approach, you can simply do the same REST API call, but instead of a post, you're going to do a delete, right? You just change the verb, and you're going to undeploy your connector, right? The URL changes a little bit because you have to specify the name of the connector in the end of the URL, but ultimately this is how you undeploy a connector, right? So, end of the first part, I'm going to pause here. Everybody takes a breath, right? Relax. And for those of you that have any questions so far, feel free to unmute yourself and ask, right? I'll be more than glad to answer them.
What is the source of data here? What data are we consuming to Kafka topic? From where are we consuming to Kafka topic?
That's a very good question. Thank you. So this sample connector that this code creates kind of randomly creates the sample data, right? So it's kind of a does in memory, all right? Just to emphasize the fact that the connector would be pulling this data from some source, but it is a generated data.
Okay. Yep. Yep.
All right. Any more questions?
So there's one from the chat here. So Aidan McCarthy asked, are there any systemd services available for Kafka Connect?
Let me read the question. Are there any systemd services available for Kafka Connect? Yes, yes, yes and no. If you download Kafka from the community, kafka.apache.org, you're going to see that there will be scripts to start and stop the services, such as Broker, Zookeeper, and Kafka Connect. And it would be up to you for creating the systemd examples, right? But there are some distributions of Kafka, such as Confluent platform, that includes the systemd for you. But it's you could write those by yourself. I mean, systemd is all about providing a start and a stop script, right? So this is very straightforward to do. And more importantly, Kafka Connect gives you the start and stop scripts. So you are halfway there. Oh, thank you, Robin. All right, so he just provided here the installation that provides the samples for the scripts. That helps. Any more questions before we move forward? Give you one, give you two. Okay, so let's move forward. All right. Okay, good. So the first point here I would like to make is this, right? So this simple code, you can use it as your starting point to start the implementation of your connector, right? So let's talk a little bit about, let me stop this Docker Compose for a second, because I will spin up later on. Let's walk you through a little bit on the code itself. So what I would like to do now, right, with your help, is, and why I need your help, because I will explain the Java classes required for building a connector, as well as which callback, Java callback method you would need to write, which one are mandatory, which ones are optional, right? And for those of you that for some reason are not following up with the discussion, and perhaps you have questions about Kafka Connect's architecture, please just shoot your questions, right? Because we're going to touch base sometimes in certain concepts that are, it requires you to understand a little bit about the Kafka runtime, right? And for that, before I forget, let me share here this link in the chat, which provides a great, very good discussion about Kafka Connect's architecture, right? Specifically, specifically the concept of Kafka Connect workers and Kafka Connect tasks, all right? This concept is important, but I'm gonna explain why I walk through the code. But just for you as a homework, study that link that I've just provided, right? So, source folder, main, Java. As you can see here in this Java implementation, Java project, we have 5 Java classes, right? But if you ask me, Ricardo, please enlighten me, how many Java classes do I really need to write? And the answer is going to be 2, okay? Specifically, you need to write this one, sample source connector, and this one, sample source task, okay? Oh, just so FYI, in Kafka Connect, there are 2 types of connectors. Sources, which as the name implies, are going to be the connectors that read the data from any sources and bring data into Kafka, right? And there will be sinks, which the data is already on Kafka, and those connectors are going to read from Kafka and send out to some other system, right? This sample code here is for a source, all right? It provides you probably 90% of the understanding that you would need for writing a sink connector, right? There will be a little nuances that are going to be different, but ultimately the packaging format, the Java classes, the logic is the same, all right? So just bear with me that this is a source, okay? That's why I call source simple source. So I've told you that you need only 2 of them. Let's discuss the first and most important one is the simple source connector, right? So let's discuss what is a simple source connector code does, right? As you can see here, it is basically a class that extends a source connector, right? If we inspect what is the implementation of the source connector, you can see that extends a connector, right? So basically we've created in the Kafka Connect framework a specialization between sources and sinks, all right? So the point here, whether if you're creating a source, you need to extend for a source connector. Whether you're creating a sink, you need to extend for a sink connector, right? It's that simple, right? When you do these extends, you are going to be forced to implement some callback methods, right? Specifically, this version method, config method, task class, and start and test configs, right? Keep in mind that I purposely skipped this validate over here because this validate I have overwrite by myself, right? You are not required. This is not, in the Java terminology, the validate method is not an abstract method from the superclasses, right? It's very simple to understand what are the abstract methods. You can simply spec the connector abstract class. But as I said, those are the callback methods that you need to write by yourself. I'm going to explain what each one of them does later, all right? I'm just explaining now which Java classes are required, right? So first and foremost, a class that is going to extend for source connector or sink connector if it's a sink, right? and you're going to implement the callback method. This is literally your connector, all right? This is your connector, okay? The second class would be a class that implements the concept of what we call tasks, okay? Tasks, as the name implies, are going to be the actual job that your connector are going to execute, right? You can put this relationship in your head if you want it. Like a connector class, a connector implementation is somehow dumb, right? Dumb in a sense that it doesn't contain any logic that is tied to reading from the source or setting to the destination. It does, the purpose of a connector class is to control tasks, like one controls the other type of relationship. So the connector creates and controls tasks. That's the job of the connector, right? The task itself is where you would literally put your logic code. For example, my job by creating this connector is for reading from a HTTP endpoint and read whatever message has been published there and bring it to Kafka. So it is the task that is going to create a socket connection to your HTTP endpoint, all right? So keep that in mind. And just like the connector, what you have to do for a task is to extend either a source task or a sync task. This is the same specialization that we've created within the Kafka Connect framework, all right? So those are the only one required, all right? The other classes that I've created here are optional, are just examples of things you can do. For example, just to create an example, right? You're gonna see that the source connector, the connector class has this method called config, right? So the whole purpose of this method config, for you as a developer, you have to return an instance of a config def, right? It's going to be the definition of all the configuration, or more importantly, the user configuration that your connector are going to expose to users. Remember this guy over here? So this is your user configuration, right? So all the parameters that you're seeing here, the first required parameter, the second parameter, all of this, you are going to actually specify here in this method called config, right? You have two options. Either you create your whole implementation that will return one instance of a config def here within a method, right? Or you can do what I've done here, which is this config def static variable belongs to this other Java class over here, where I simply made available as a public static final, AKA a constant in Java, right? And you can simply reference from other Java classes. So why I have done this? Just to follow the best practice of unit testing. So that way I can unit test my whole user configuration logic here that only does user configuration logic and separate from the connector architecture, right? So I made it more testable, if you will, right? Does it make any sense? Does anyone has any questions so far? Yeah, go ahead.
So when you say it returns the config dev, that means it's an output of that connector, right? Source connector. It's give out something.
Correct. It's an output of this method of the connector. Yes. Yeah, the config method specifically. You're correct.
Yeah.
Yes. Good. Okay. So yeah, there you have it. So this class here, I've just basically externalized the whole definition of a config def. But ultimately, what you have to do, a config def is where you define your parameters. For example, right here, you see this method parameter, add parameters that I've created here. So I've treated this config def as kind of a global variable that I've keep been sharing across Java classes. And then you can simply config def.define method, and you can specify the name of the parameter, the type of the parameter, if the parameter is imported or not, and optionally a Java doc. No, it's not a Java doc. Take that away. It's just a doc or documentation, because there are some operations for some connectors that you can simply run a command, and then you can kind of generate automatically the documentation for the parameter, right? So usually this is only used if you are going to publish your connector into a repository called Confluent Hub, but I'll talk about that later. Yeah. Okay, so let's move forward. And then, like I said, you have this task class here that you need to create, because where they're going to write your logic. But one of the things that you are going to optionally create in your task classes, specifically if you are creating a source connector, is what we call a monitor thread, right? Let me explain this very carefully, all right? So let's take the example. I like to use databases as examples because these databases are something very simple to understand, and arguably this is the building block that any developer will easily understand, right? So databases are basically built up by the concept of tables, right? This is how you store data on databases, right? You put them on tables, and you might have one or multiple tables in a given database, right? So imagine that you were writing a connector that are going to read data from a database, specifically read data from tables, right? And by the time you deploy the connector, that database had 10 tables, for example, right? And then the connector is deployed, everything's working, but the database evolves to include more 2 tables. So now it no longer have only 10 tables, now it has 12, right? From your connector standpoint, the connector doesn't know about these 2 new tables, right? So it will constantly keep reading from only the 10 tables it was know about by the time it was deployed, right? So a way for you to overcome this, in quote, limitation is to provide, along with your connector, what we call a monitor thread, right? And this is exactly what I've created here. And by thread, I literally meant it. I mean, it's basically a class that extends thread, or you can simply, like some people like, instead of extending thread, you can always create your class that implements a runnable. Yeah, be my guest. I mean, it works the same way. You have to create a Java thread for this, right? And what these threads are going to do is to, like I said, periodically, from time to time, read the sources in the example that I gave, the database, to monitor if there are new tables, or perhaps not new tables, tables that have been removed. You can deal with the situation as well, right? I mean, maybe originally there was 10 tables, but now there are 8 because 2 of them has been dropped, right? So you have to tell your connector this, right? Because you have to make your connector a little bit more intelligent and dynamically reconfigure itself. How you do this? You create a thread, just like you did it. I did it here. And if you inspect my connector class here, you're gonna see that within the start method, right? I do some code here to read all the configuration from the configuration file and store it in local variables. But ultimately, look at what I've done here as well in my connector class, right? I spawn a new thread from my connector whose objective is going to be, like I said, be monitoring that reconfiguration of the source that has been written, right? And in the thread itself, I'm going to show you the logic here that I've wrote in the run method of the thread, right? So I've created a random illusionary kind of whose purpose is only for educational, right? To simulate a situation where randomly it would change the sources to be read, right? Just to make sure that you understand the concept, right? Technically, this would be more like a poll that you would read from the metadata of your source system, something like this, right? The point here is, once your thread detects that the source system need to be reconfigured, you have to call this method here, request task reconfiguration, by this guy here called context, right? And where this context came from, basically this context is something that your connector class here, right, is going to provide for your thread, right? And by the time you create a class that extends source connector, the context variable, which is a protected variable in the superclass, is been given to you automatically. You simply use this variable, and pass through threads or whoever is going to need it for this. Does it make any sense? Any questions so far? Nope?
Nope.
Okay, let's keep going. Either you are understanding everything that I'm explaining, or you are not understanding anything, right? So we'll see in the end. Okay, all right, let's move forward. So I think I gave you a clear picture about what Java classes are required and which ones are not, right? So like I said, you have to create a connector, you have to create a tasks, right? So now that you understood this, let me walk you through a little bit about the methods and what is the responsibility of each one of those methods, right? But before I explain this, let me show you this diagram here from one of those, that link that I've provided on the chat before I start this part, right? So this diagram here kind of emphasizes the relationship between what we call workers, right? Connectors and tasks, all right? So here's the thing, all right? Kafka Connect follows the same distributed design of Kafka, right? So what that means is that Kafka Connect by itself will be composed by lots of JVMs, right? How do you create a Kafka Connect cluster? You spin up lots of JVMs, and if the group ID of those JVMs is the same, they will form a cluster. It's that simple. It's a property called group ID that you go there, you set. If they match it, they will form a cluster. If they don't match it, they will form their own clusters, all right? But ultimately, they're going to be a bunch of JVMs running on top of a given infrastructure, whether if it's bare metal, Kubernetes, containers, or cloud, right?
Are you talking about cluster of connectors, is it?
Correct. Yes. Ultimately, I'm about to talk about cluster of connectors, right? So right now, I'm talking about the foundation of this, which is the what we call workers, right? So every time you spin up a JVM with Kafka Connect, this is called a worker, right? As the name implies, it's going to work to do something, right?
Yeah.
But here's the tricky part that I would like you to understand. Every time let's take this example here, for example. We have 3 workers, 3 JVMs, okay? And then you've just wrote your connector here, you've tried to deploy, right? And he's going to deploy it successfully. How this is going to work? Your connector, you see this Java class over here that is represent your connector? One instance of that class will be created and only one of those workers, all right? We call those the master worker. Oh, Ricardo, which worker is going to be selected? I don't know. Nobody knows. You can call the universe and nobody will actually explain that to you. And there's a reason for this because, as I said, it's a distributed system, right? So the cluster will elect one of the workers, probably a less busy worker, to deploy that connector. And by the time that worker is deemed like busy or dead, the cluster will kind of shut down that connector and kind of redeploy that connector automatically without your interruption in another worker. That's the reason why we should not know which worker is selected, right?
Yep.
The point is, it's a singleton, literally one instance. One instance of your connector will be deployed in a given worker. However, all right, and this is a good relationship for you to understand. Your task is going to be probably more than one. All right, I'm gonna teach you what is the granularity and the relationship between tasks and your systems. But before that, what you need to understand, your tasks are going to be spread over across the cluster. In other words, across multiple workers. All right. So for example, just for example, imagine that we have 3 workers here and we create 3 tasks. Literally, each one of those workers are going to have received one of those tasks. Another example, we have 3 workers and we have 6 tasks. What's going to happen? Each one of those workers is going to host 2 of those tasks, right? And so forth, so on. This is how the deployment architecture of your connectors works, right? Again, you don't control, you as a developer, you don't control which workers are going to end up each connector or tasks, right? You simply deploy, okay?
Yep.
That good so far?
Sorry, Ricardo. One question.
Sure, go ahead.
I see. Sorry, in the page, here, you said that the connector is only one. It's a singleton, but I can see here there is con1 in the worker 1, in the worker 2, and the worker 3. What that means? Is a different connector or?
You got it. Those are different connectors, like connector 1, connector 2, and connector 3.
Yeah, but is one, so in the first box is connector 1, and then the second box connector 1, task 1, and then in the worker 2 is connector 1, task 2. It's different connector because all of them is called connector 1.
Yeah, probably here, those are different connectors, but what in reality, only one instance of the connector are going to end up in one of those workers, right? Maybe actually you just highlighted something that might be wrong with this image, right? So maybe this is
but I think this it means that, for example, I think it seems that connector 1 has got three tasks, and if you look here, task 1 assigned to worker 1, task 2 assigned to worker 2, and task 3 assigned to worker 3, and those 3 tasks are related to connector 1. And I think there is another connector 2, which has got 2 tasks. One is task 1, task 2, and I think connector 2 has got, task 2 of connector 2 assigned to worker 1, and the task 1 of connector 2 assigned to worker 3. It seems okay to me.
Yeah, no, yeah, I think you nail it. So for example, I think here is only 2 connectors. So connector 1 has been, it lives on worker 1, and connector 2 lives in worker 2, right?
Yep.
And like you said, correct. So connector 1 has task 1 and 2 and 3 spread over worker 1 and worker 3. Yeah, that's correct.
Yeah.
Makes sense. Yeah, at least the image is not wrong, so less work to do. Thank you for the help. All right, so let's move forward. Right. So now that we understood a little bit about what Java classes are required, which ones are optional, the relationship between connectors and tasks across the Kafka Connect runtime, let's dig down a little bit about the methods that you should write, right? Some of them are really easy to understand and implement, right? Most of them are going to be like a, how they call in English is boilerplate code, Like, you know, those codes that is always the same and never changes. There's a name for this, right? How would they call this? Placeholder, boilerplate? Boilerplate, yeah. I'm from Brazil. That's why I kind of lack a little bit of vocabulary in English. So forgive me for that. So yeah, it's going to be a boilerplate code. For example, the version method. I mean, this is literally a method that needs to return a string with your connector version, right? And although the implementation is really easy, it's really powerful what this does, right? Because in runtime, imagine this. Imagine you have deployed the version 1 of your connector, right? And it's deployed. It's literally working and all of that. If you come up with a new version of your connector, and you should update here the method to return a new string of that, and you try to deploy this new version, the Kafka Connect framework are going to handle this automatically for you, right? It's going to detect, okay, there's a connector, the same connector has been deployed again, but this is a new version. So a lot of technicalities are going to happen behind the scenes, such as, all right, I'm going to pause all the threads for this old version of the connector, and I'm going to smoothly unload this from the class loader for each one of those workers while I am loading this into a class loader and deploying to multiple workers. When all of this happen and finish, I'm going to resume the threads, and all the new threads are going to be executed on the new version. All of this are managed to you automatically, right? If you're the old days Java developers, just like we would do in a container-based technology for Java E, right? You would simply deploy a new version of your AJB or servlet or Future, and all of that would happen automatically in a distributed environment, right? This is the same concepts, right? But it's up to you to specify a fine control about the versions. But all I have to do is return a string. And then I explained the config method, so I'm going to skip this one. Hopefully it's understood at this point. Another boilerplate code, simple to implement, task class. As the name implies, all right, I am the connector, and I have to provide which implementation of the class that's going to build up my task, right? So you have to literally return a class of your task class, right? So like I said, boilerplate code, no big deal over here. I'm going to skip for a second this validate method. I will come back to this, right? Because as I said before, this is not mandatory. You're going to do this optionally if you want it, right? And I'm going to skip to start and task configs. Start, as the name implies, you're going to do something that you were required to implement this method because it's an abstract callback from the superclasses. However, you can simply put the start method here that doesn't do anything, right? You're not forced to write any code here at the start method, unless you want to do something like do resource management. In my case here, I kind of control the life cycle of my inner thread over here in the start method, right? At the same time, in my stop method, I'm shooting down my thread, right? So this is how you control the life cycle of your threads, for example. Or it doesn't have to be threads. Any external resources that you are going to need for the behavior of your connector, right? It makes sense. Okay, so start and stop. Let me explain this task configs. This is arguably probably the most complicated method that the Kafka connector framework has, right? Hopefully it's not going to look like so complicated to you, because I have heard that the London Java user group are probably one of the most talented Java developers in the world. So I think you're gonna nail at this, right? But let me explain this way, all right? One connector spin ups one or multiple tasks, right? How many tasks you are going to spin up, all right? This is controlled by one property that the user are going to specify here. You see this parameter here called tasks.max, right? This is a global parameter. You don't even need to specify this in your connector, right? All connectors are going to share this property. So let's say that instead of 1, I would set here like, I don't know, 5, for example, okay? And then this number 5 over here would end up here as the parameter over here, mask tasks. So whatever you set there is going to end up here, all right? Why? Because this is the user telling you as a developer how many tasks concurrently it wants to spread over the workers, right? Why is that? Because you as a developer, you don't know the future Kafka Connect cluster, how many workers you're going to have, right? You don't know this information, and you should know, right? You have an idea that it has at least 1 JVM running, right? You hope for this, right? Or might have 10,000 JVMs running. You don't know. The point is, given the number of tasks that the user wants you to spin up, right? You are going to factor that number into the amount of actual tasks that you need to create, all right? So let's take a brief, right? Because as I said, this is a little bit complicated to understand, and let me insert an example here in the explanation. Imagine that the user specified the max tasks of 5, okay? So the number 5 are going to end up here. However, this is a connector that is supposed to read tables from a database, and after discovering the amount of tables in a database, you realize that there are only 3 tables on that databases. But remember, your user wants you to create 5 tasks. So what are you going to do, right? You're going to do what we call some trickery, like this one over here, to kind of match up the number of tasks that you actually need to spin up versus the number of tasks that is currently possible to spin up, right? So in this particular case, the example I gave, you won't create 5 tasks because there are not 5 tasks to create, right? You're going to spin up 3, each one for each table to be read, right? So you're literally kind of going to ignore what the user said, but the inverse might happen too. What is the inverse? The inverse is that the user specified 2 tasks at tops to be created. Still, you have 10 tables to read in a database, right? So what you are going to do, you are going to do some trickery, just like I've done here, to make kind of a, okay, 2 tasks is the maximum tasks I have to create. How many jobs I have to create? 5 per task. So you're going to allocate the number of actual tasks into the task instances that you were allowed to create. Please let me know if does it make sense to you.
If you explain the last example once again.
Sure.
Yep.
With pleasure. Let's say that the user specified here in the configuration file that it can only create 2 tasks, perhaps because there are only 2 workers in the cluster, right? So this is the user telling you how many tasks you are maximum create. And it is your job here in this method, task configs, to pick up that number and you have to match up and conciliate with the number of tasks that you really need to create. So for example, the database that you need to read has 10 tables. So in an ideal world, you would spin up 10 tasks, right? One for each table to achieve the maximum of parallelism possible. It's not parallelism, it's concurrency, technically speaking. But the point is, you cannot spin up 10 tasks. You can only spin up 2 tasks. So what are you going to do? You're going to divide and conquer. You're going to divide. Each task are going to receive 5 tables to read. Make any sense now?
Yeah. Got it.
You got it. I think the inverse example is better to understand that the previous one, right?
Yeah.
I'm going to start with this one in the next time I present this. Thank you.
Question. So does this task refer to Kafka producer or Kafka consumer behind the scene?
Perfect. Thank you for this comment. Yes. So if this is a source connector, you were right. This is going to become a Kafka producer. If this is a sync connector, this is going to become, sorry, is the inverse?
It's the other way, yeah.
Yeah, the other way around.
Yeah.
If this is a source, it's going to be a consumer. If it's a sync, it's going to be a producer. Yeah, right. So yes, however, you actually don't need to write those, if it doesn't make any sense. What you write now as a developer is this high-level code here that manages and creates tasks, right? And you no longer have to create Kafka producer. So we kind of abstracted away a little bit of the complexities of the client API of Kafka, right? Because ultimately, Kafka Connect runs on top of the Kafka client API. Making sense?
Yep, thanks.
Perfect.
And another question. So you said that in the example of having the user saying that you want to have 2 tasks, and you have like 10 databases, you will create 2 tasks because you have to, and then you say each task will read from 5 databases. That means that when you create 2 tasks, you create 2 threads only, or you can have like 1 task with 5 threads, or how it's gonna?
Thank you. Your questions are amazing. That's what I've been told, that the London Java community users are the smartest people on the world, right? Your questions are amazing, right? You are absolutely right. Each task equals to a thread, okay? You are perfectly in sync with that. However, and this is the important part, is not for the task relationship, you as a developer don't spin up that thread, right? This is handled by the Kafka Connect runtime framework. Reason why, let me go back here in the source connector. Your connector simply, where is it? Yeah, simply returns which class. This is you communicating to the runtime. Here, runtime, this is the class that you need to spin up when you need to create a task and a thread to host that task. But you were right. Each task equals to a thread. It's concurrent execution of code. Make sense?
Yeah, thank you.
All right. Thank you. Okay, so
Ricardo.
So I explained task configs. Hopefully this is understood. So basically this controls, you have to come up with a list of a map of strings that basically the size of the list is going to be ultimately be the same size of the mass tasks that has been created here. That's how the runtime framework knows how many tasks to create, right? And remember when I told you that this validate method over here, you are not required to implement, but there might be situations where you would like to validate specifically. Usually when there's a built-in logic that only you and your connector understand. For example, in my case here, I have this logic that either the first required parameter has to be set or the second parameter has to be set, all right? And why this is important? Because when you define your parameters, you can define that each one of them are required, all right? And which one of them are not required. But sometimes you might have logic is the same. Okay, if the user set X and Y, it should not set the Z, and you would like to validate and ensure that the connector has this behavior, right? Because otherwise, your connector logic is going to break. Just an example, right? So This situation is better handled if you explicitly override this method validate and you put the logic here, all right? So all you have to do is to whatever is not in is not in conformization with your logic, yeah? You should throw this connect exception over here with a custom message and the parameters, and this connect exception is going to instruct the runtime framework to stop whatever deployment is going on, and is going to literally stop the overall deployment of any tasks, right? So this is a way, this is like a Java developer would like to throw a runtime exception, for example, in a container word, right? It literally stop everything. I don't want to continue. Making sense?
Yep.
Okay, good. All right, I think we are almost by the end of our time. We have 3 minutes, so let me explain the task class very quickly. Let me ask you this first, because I would like to honor the time that you have. If we like spend, instead of 3 minutes, 5 minutes, that'll be okay for everybody?
Yep.
Okay.
Go ahead, no problem.
Okay, good.
Yeah.
I just want to be respectful with your time, because I know that in London it's quite late, right? And so for me, I'm okay because it's kind of a 3 p.m. in the afternoon, so I'm good. Okay, good. So let's talk about the tasks, right? So this is kind of a simple to understand as well. There's a little bit of some gotchas that you need to take care of here in the task class, but just like the connector, you have to also return a version. It's kind of weird because you are already returning the version of in the connector class, but here's the tricky part that might be useful for you. You can have different versions of the same connector, but different versions of tasks running at the same time in a Kafka Connect framework, right? So you can control this behavior by using different versions over here, right? But just like the connector, just return a string. You still have the start and the stop method. Usually, like I said, they're basically optional, right? You don't need to actually put extra logic here to control unless you are handling external resources and you're gonna need to make sure that their life cycle is controlled here, right? And then you have the pull method, right? But before I actually get into the merits of this pull method, let me explain something very important, right? At least for me, because I'm dumb and I've made this mistake when I was learning this. This might not be something that you would do, right, as well, but it is my job to give you this heads up, all right? This might not be so clear at first. You might see that this connector class, as well as the task class, they are going to be packaged into the same deployment archive, right? So ultimately, it might give you the idea that they will be spin up in the same class loader within the JVM, right? It has some logic if you think about it. However, just like the understanding that you've got before, the connector instances are going to be necessarily running on the same worker or JVM from your tasks, right? Even though, this is important, even though they might end up in the same worker, but they're going to belong to different class loaders, okay? What this means to you as a Java developer, that your task class cannot use any variable reference from your connector. So it might be tempting, for example, for your Java task class to simply reference this guy here called monitor thread, because hey, they might be in the same class loader, right? So I can simply reference. If you try to do this, you are going to end up with a new pointer exception, right? Because again, they belong to different class loaders, right? So here is the thing that I would like to emphasize here. Be mindful about your task implementation logic. Make sure it is 100% stateless. It has zero dependencies of any external resources, because in any given time, the task execution can be discontinued from one worker and move to another, right? And when that happens, right, it cannot have references to anything that was local to that broker or to that JVM. Does it make any sense? You have to make sure that your task classes are idempotent, all right, or stateless at tops, okay?
Yep.
No stateful logic, nothing that spins to a specific broker or JVM or machine. None of this, right? Make sure they are horizontally scalable, right? That said, let's continue with the poll, which is the last and most important method that I would like to explain here. And literally, as the name implies, is where when your task is going to poll for data in the source system, right? I like to use the, like I said, I like to use the databases as an example because they are simpler to understand. So I'm going to use it again here, but hopefully you can abstract that applies to anything, right? For example, I've created a connector for Apache Pulsar, right? And this connector basically treats Apache Pulsar as my source systems and the topics from Pulsar as my tables, right? So like I said, the example applies to anything. So imagine that this connector over here is going to read data from tables on a database, right? So where you would put the logic of reading that data here on this method poll. This method here, remember that task is a thread, right? Just like we discussed it before. So because it's a thread, it will execute continuously this method over here. Think about a public void run method that the only line of this public void run is called this method poll, right? So what's going to happen if you deploy that thread is is an infinite loop that keeps calling that method from time to time, right? So it's up to you to periodically make some pauses, to periodically or not, or maybe you are dealing with something that needs to continuously keep reading from the source. So you simply write here the code that read from the from your source system, whatever the source system is, right? What you have to do as a Java developer, it is your job to return a list of a source record, right? So this entity here called source record, if you inspect this class over here, you're going to see that it has several overloaded versions of this constructor where you can whether pass the partition, the offset, the topic, partition, value schema, blah, blah, blah. It has a lot of, I would highly encourage you to read the Java docs to understand a little bit about the version that you have. But there is only one thing you need to understand about this. Sorry, I close it, open again. There is only one thing that you need to understand about this source record class, right? This is where you're going to put your data that you read from the source, okay? But this is not a simply wrapper from your data, right? You have to put some additional information that makes your data more controllable. For example, you have to specify, okay, where this data came from. We call those sources, right? Imagine a source would be, for example, a table, right? Within the database is broken down into multiple tables, and each table is a source of data, right? Within that data, within that table, you have a cursor that knows the position of which row it was read, right? We call those offsets, right? It is interesting for you as a developer to specify which offset that row has been read. Oh, Ricardo, why? Why? Because imagine that you've deployed a connector and the connector was doing its job, which is reading from the source, and something happened with Kafka Connect, all the brokers goes down, right? So you're gonna have a pause on your consumption throughput, right? When they come back, what you would like them to do? To start Rover from the beginning where they started the reading from the tables, or from the point where they would start reading by the time they were paused? Probably the later, right? So in order this to happen, you need to provide the source and the offsets, right? Because otherwise, you're going to see this behavior of, okay, every time I deploy the connector, it starts reading all over again from the beginning. And sometimes you don't want this because you might be working with millions of hundreds of thousands of records, and you don't want to consume all that time all over again every time the connector is deployed, all right? So I'm going to pause here forcibly because we reached the maximum time we had for this presentation. Let me ask you this. Any questions that you might have so far? Specific ones, generic ones?
I do have
Ricardo.
one.
Go ahead.
You said that the connector has the task, and if the task can goes down and spin up in another JVM, if the connector goes down, that will take all the tasks that has that connector, or just go the connector down and spin up another connector?
Good question. Thank you. No, the tasks will be continue to be deployed. Okay, this is important. They would continue to be deployed, but they would be paused until a new host for the connector is found. All right. So the whole execution, we call this the connector would be in pause state.
I've got one other question as well. You know about the fact that the tasks and the connectors are loaded into different JVMs. So, and you said, well, you can't refer to anything from the connector in the task, right? So, which other classes are loaded into like different JVMs? Is it just the tasks, or the other classes which are loaded into different JVMs?
Good question. Good question. So, any classes that build up your class path in your dependency system for your implementation would be loaded within that task as well. So, for example, you are writing a connector that's going to read on a database using JDBC. So all the JDBC drivers would be loaded up within the same class loader with your tasks, right? So yeah, but for the Kafka Connect framework point of view, only the task classes and the connector classes, those are going to build up the class loader for this purpose. There are no, like there's no such thing, for example, when we have in other Java frameworks, like a dynamically injection of class loader with external functionality. It's only those ones.
Thank you.
Ricardo, there was a question in the chat some time ago when you were speaking about versioning. Do you need to use semantic versioning for Kafka connectors to work?
Good question. So I would presume that by semantics is because we might have the connector versioning, which might follow a pattern. For example, connector 001, and the task might be task 001. And I would presume that the semantic, if it's the connector semantic, needs to follow the task semantic. And the answer is no. They are strings that needs to be the same in a given point in time. So how the connector, the Kafka Connect runtime framework is kind of a dumb in a sense that it only worries about detecting if the version or the string change. If the hash code of the string change, then it's going, okay, so it wants me to deploy a new version. That's okay. But it doesn't have to keep up with the connector and tasks, if that's the question.
Yes, it was the question. Thanks.
Perfect.
I have a question. So, is it possible for the connector to, implement something like a work stealing mechanism that we have with executors with respect to the incoming tasks from the different JVMs?
Can you ask again? I didn't quite catch that question.
Yeah. So, I'm just curious to know about the way the tasks can be handled from the connector's perspective. I'm just wanting, curious to know on the lines of work stealing mechanism. So we have executors which deal with work stealing pools of threads. So is it possible to leverage that over here?
Oh, I think I got it now. Yeah. No. So all the worker threads and pool of threads, it's controlled by the Kafka runtime framework. So the only promise that you have as a developer is that rule number one, your connector instance is going to be only one thread. Promise number two, each task is of yours. How many of they are is going to be spawned up in one given thread, one exclusive thread. But no, you don't control executors or pool of threads or where those threads came from. Fortunately or unfortunately, depending on point of view.
Thanks.
Sure.
Ricardo, I have another question that's more conceptual than anything. But for the end user, what would be a good use case to actually write your own connector? I mean, you already have like JDBC files, S3, whatever you name it. So like, if you're not a vendor, why would you write your own connector?
Okay, so let me explain this with an example. And I am going to really be very shameful example because I'm going to literally show to a Java group of developers a code written in Golang. So I am sorry. I know that this is kind of a disrespectful, but it will help to prove the point that I'm trying to make, right? So bear with me for a sec. Can you still see my screen, right?
No, I think you haven't shared your screen yet.
Really?
I think you stopped sharing your screen, yeah?
Okay, so let me share again. Okay, tell me if you're...
Yep.
Okay, good, thank you. So I'm gonna use this example here that is a Go code. I'm sorry about this. I love Java, but in this specific case, I had to write a Go code. I can tell the reason later on, but the point here is gonna help us to answer your question, my friend. So if you ask me, there is a connector available for Redis cache, okay? But then I have to build a system over here that has this particular behavior where every time I would read data from Kafka to send data to Redis, I would need to leverage this concept of multiple transaction in Redis because I would be writing into two different caches, right? And it needs to be, for my particular use case, it needs to be an all or nothing situation where, you know. So back to your question. Oh, Ricardo, there is a connector for Redis already. Why didn't you leverage this? Because the behavior that I was looking for was not present on the existing connector. So I need to create my own connector to leverage those capabilities, right? So the same applies for anything that I have seen thus far. I have seen situations, for example, that people, though you have a JDBC connector, but they want to control certain aspects of the database by some logic that only makes sense to them or for the companies they work for. So those are the situations that you need to create your own connector. And obviously, of course, right? I think this is obvious when you are dealing with a technology that doesn't have a connector, right? So that's why you need to create your own. Make sense?
But more than fine. Any other questions from anybody?
Just an FYI, guys, I'm not rushing out to finish the presentation, right? I'm just being respectful with your time. I would love to stay here for the next 2 hours answering your question. I would love to, but Anthony, which is our currently host, might not be all this time available. That's the bottleneck.
I'm okay as well.
Actually, I had a question, actually.
Sure.
Yeah, it's just around, like curious, like it's kind of around Mirror Maker 2, which I think uses Kafka Connect under the covers.
Yes.
And I was thinking like, I was wondering if Connect generally, and maybe Mirror Maker 2 has like a way to plug in and a way to kind of transform records as they go through Connect from source into sync. Like, I guess the use case would be like, I had in mind was like, so let's say, for example, you're streaming data from one Kafka cluster to another using Mirror Maker 2, but you want to kind of obfuscate anything GDPR related. Is there kind of some way to do some sort of transformation or obfuscation of that type in the Connect framework?
Yes, very good question, by the way. So there is two aspects of Kafka Connect that I intentionally didn't talk about in this presentation because it would run off the subject of creating custom connectors. But there is two things called, one of them is SMTs, the acronym for small message transformations, right? And there's another thing called converters, all right? As you might have get the glimpse idea already, they allows you to perform in-flight transformation while data is whether being brought from the source into Kafka or whether the data is being brought into from Kafka to the system. You have this in-flight processing engines, if you will, that you could use for like the example you gave, to do some obfuscation on records. And I might be wrong or right, but I can double check with Robin, which is the expert in Kafka Connect. But I think there's an out-of-the-box SMT that does obfuscation already. So you don't even need to write code for this. It's just a plugin, just subscribe your SMT and your connector will leverage this automatically. So yeah, it's possible.
Cheers. Thanks.
Any other questions?
I think there's a question here in the chat. Can you please explain again the 2 tasks and 10 tables example means how to test reader again? Yeah, so in the example I've gave, so the user requested for the connector to spin up 2 tasks at tops, right? Again, because this might be an environment restriction where you only deal with 2 workers, for example, right? So the point is only 2 tasks at tops. However, the amount of workload that you have to do in the source systems, it goes beyond 2 tasks, right? And just to remember, each task represent a unit of processing, right? So an example of the databases, right? If you have a database with 10 tables, it is kind of a rational that you would spin up 10 tasks, each one for each task for each table to achieve the maximum level of concurrency and parallelism, right? Otherwise, each table would have to be stopped reading, and then you give chance to another table if you deal with a smaller number of tasks than you read tables, right? So in the example I gave, if you have only 2 tasks and 10 tables to read, each one of those tasks would have to read 5 tables, meaning that one given task would have to circle back between 5 tables differently and different times, right? So it won't be concurrent. It will be serial, right? So does it make any sense? So this is how you kind of match up the relationship between tasks and the sources that you need to read.
Thank you.
Sure.
There was another one in the chat, and I'm right in thinking the source record can be used to save a task state or properties if a task gets migrated.
Good question. And I am sorry to say that I don't know. I think I can double check for you, please. Let me share my screen again, where I can provide my email and my context. But I think the answer for now is that my perception, where's the presentation? Here. My perception is that here's the my context, my email from Confluent and my personal email and my Twitter handle. My perception is that the source record is transient, right? So what I mean by transient is only use it in that very brief period where the Kafka Connect framework needs to receive the data that has been read from the source and write into Kafka. So in other words, it's going to spin up a Kafka producer, writes into Kafka, and then that's it, right? So I'm not sure in a migration scenario if all the metadata, if you will be saved in the source record. I really don't know. I arguably would say that no, but I don't know. That's the answer. Sorry.
Any other questions? If not, Ricardo, like, massive thank you for the great presentation. Like, a round of applause to Ricardo.
Thank you. Thank you. I appreciate it. Yeah, glad you like it.
Cheers. And this is being recorded and it will be made available by Barry someday in the future. Okay, guys.